This is Unit 5, Day 3 video. And today we are going to talk about graphing circles. You are going to know that what you're graphing is a circle if in your equation you have an x that's squared and a y that's squared. So you'll notice that this x is in parentheses that are squared and this y is as well. So the double squareds imply that you are going to be having a circle that you're going to graph. After you identify that you have a circle, what you see inside your parentheses are going to be the coordinates of the center. So you literally just have to pick that out. The number that you have over here is going to be your radius squared. So you should be able to figure out the radius. If they give us a question like number 1, where we are writing the equation of a circle whose center is at this point, we know the h and k value, and we know the r value for the radius. And I am literally going to plug that information into the above equation. So you can see the above equation right here. So I'm going to rewrite that, x minus h squared plus y minus k squared equals the radius squared. And I'm going to substitute in. When I substitute in, this is x minus what's h, 4, squared plus y minus, because it comes with the formula, negative 1 squared equals 2 squared. In a situation like this, the x minus 8 or x minus 4 squared is totally fine, but what happens when you have minus and negative is it turns to positive. So this is going to say y plus 1 squared, and we have to simplify 2 squared and get 4. So this right here becomes the equation of our circle. It's kind of a long, obnoxious equation, but if you remember that these two things give me information about the center, and this gives me the information about the radius, that's enough information to graph the circle. Please notice that in these problems, if you have a positive 4 over here, when you put it into the equation, it's going to be negative because there's already a negative there. If you have a negative 1 on it and you put it in, it's going to become positive because there's already a negative on top of your negative, and 2 negatives make a positive. So in your eyes, it's going to look like that sign changes. The number on the end, if you want to find out the radius, you square root that, and it's going to give you that the radius is 2. So this pattern we just keep repeating again and again. For question number 2, in parentheses, x, this is positive 9, I'm going to put a minus, plus, and notice I'm following the same form, y minus 0 squared equals, and this 3 gets squared, giving me 9. I literally am just dumping into that formula. Now, this one can be simplified a little further because y minus 0, think about that, anything minus 0 is itself. So my final answer, x minus 9 squared plus y squared equals 9. Question 3, if the center is at the origin, we know the coordinates of the center are 0, 0, and if we were to put a 0 into these two places, it would just be x minus 0, which is x squared, y minus 0, y squared, equals, and then it's the square root of 5 squared. So anytime that you have a 0 for the x or y coordinates of the center, you just put x squared or y squared, whichever one it is. In this case here, remember we did that unit on radicals. We know how to simplify this, and the square root of 5 squared is 5. So technically right here you can just put a 5, and should put a 5, you should reduce it back. Questions 4, 5, and 6 have the reverse. They're giving you the equations, and they want you to tell what the center and radius is. So for this question, the center is exactly what we see numerically, except they're the opposite. So if I see a plus 3 in the equation, it's negative 3. If I see a minus 10, it's positive 10. To figure out the radius, I'm technically going to square root that 64. So I'm going to get that the radius is 8. So if I was going to graph this circle, I would go to the point, negative 3, 10, and do a radius of 8. Question 5. If it's just x squared and y squared, your center is 0, 0. In this case, the radius turns out to be 4. The next question, center will be positive 5, 0. Your radius is the square root of 20, which is radical 4, radical 5, which is 2 radical 5. Do not forget to simplify the radical if you need to. The two questions at the bottom tell us how to graph a circle, and we technically need two pieces of information. We need to know the center, in this case 0, 0. Radius, how big is your circle? Square root of 16, which is 4. So I am going to go to 0, 0. I'm going to count 4 up, down, right, and left. And then I can draw my circle. If you have a compass, you can use a compass to draw your circle. If you feel like you can do a freehand one pretty good, I'm okay with you freehanding this. I don't know if you'll want to do that on the back, but at least here. It should look like a circle though, not a flattened out square. When you graph these circles, you need to make sure that you include the x and y axis labeled, and the equation of the circle goes on the circle. Now, x squared plus y squared equals 16 is a pretty small equation. So we'll talk about what happens when you look at the next question. Graphing it, we need the center, 1, negative 3. Notice the sign change. Radius 6. So I'm going to 1, negative 3. I'm counting 6 in every direction. There's where my circle is going to sit. I'm going to try to draw a somewhat decent circle freehand. If you can't draw one freehand, many of you I'm sure have a compass. There's my circle, label the axes, and this equation, sometimes what I'll do is I'll start way over here because I know I've got a long equation. And there it is. Now on the back of this page, we're going to be graphing circles and lines, or circles and parabolas, to find the points of intersection. So we're continuing with this circle idea. On the back, question 9, I have two things to graph. The first one, notice it has an x squared and a y squared in it. That means that it's a circle. Center of my circle, 0, 0. Radius, 4. When I go to the second thing that's here, this one, if it's x to the first and y to the first, whoopsie, y to the first, I know that it's going to be a line. I want to have this line written in y equals mx plus b form. So I have negative y equals negative x plus 4. Divide everything by negative 1. Y equals x minus 4. Slope, 1 over 1. Y-intercept, negative 4. So I go on the graph to this, up 1 over 1. And we talked previously, at least I talked with some of you about how obnoxious this can be. I'm going to draw a straight line through those points. There. So when I draw the straight line through those points, I'm going to start down here. I'm not doing that. Hang on. So I want to pick a line. Here's where the line's going to go. This is x minus y equals 4. I also need to graph that circle. I go to 0, 0. I count 4 in every direction. Notice when I count 4 in every direction and graph my circle, and you may want to use a compass for this if you're not good at drawing these. You need to find nice points of intersection. I can see that my circle and my line intersect in two places, here and here. So when they intersect in those two places, one of my solutions is 4, 0. One of my solutions is 0, negative 4. Because I have two solutions, that means I should be doing 4 checks. So if I go over to the side to write those 4 checks down, I'll try to squeeze them in here. This equation needs to get checked with 0, negative 4. So that'll be x squared plus y squared equals 16. 0 squared plus negative 4 squared equals 16. 0 plus 16 equals 16. 16 equals 16. That checks. But that same equation also needs to get checked with 4, 0. So x squared plus y squared equals 16. 4 squared plus 0 squared equals 16. 16 plus 0 equals 16. 16 equals 16. And that checks. There's 2 checks. However, I also have to go back and check in this equation. So this one needs to get checked with 0, negative 4. X minus y equals 4. 0 minus negative 4 equals 4. 4 equals 4. And then that same equation has to also get checked with 4, 0. X minus y equals 4. 4 minus 0 equals 4. 4 equals 4. So there's 4 checks and they all checked. You're responsible for doing all 4 of them. If I was doing this on a piece of paper, I would probably make it a little neater, but that's okay. You can see what I did because I changed the colors. Question 10, same idea, a little bit more involved. Not terrible though. In question 10, this first thing that I'm graphing is a circle. The x is squared, the y is squared. The center of the circle, negative 3, 2. Radius is 3. The other thing that I'm graphing is a line, x to the first, y to the first. So the first thing I'm going to do is add 2x to both sides. So 2y equals 2x plus 4. Divide by 2 across the board. Y equals x plus 2. This is a line. Its slope is 1 over 1. Its y-intercept is 2. I go to 2. Up 1, up over 1, up 1 over 1. So eventually I end up having a line that does this. I'm going to draw that line in there. There's my line. The equation of that line, 2y minus 2x equals 4. I think I forgot to write the equations on the previous one. I should probably go back and do that. I have to graph my circle. Center, negative 3, 2. Radius, 3. Here's my circle. How many points of intersection between the circle and the line? There are 2 of them. That means in this particular case I have 2 solutions. I have one solution here and one solution here. This one 0, 2. This one negative 3, negative 1. 2 solutions. If you were to do checks, please know that there would be 4 checks that you would be required to do. Each solution needs to get checked in each of the 2 original equations. The circle equation, x plus 3 squared plus y minus 2 squared equals 9. I'm going to go back. It kind of bothers me that I did not write the equation of the circle on this one. So I'm just going to go back and catch that. Equations should be written on everything. So once you know how to graph a circle, you can find out where circles intersect, 2 circles, a circle and a parabola, or a circle and a line. You have to be able to write the equations, which you're obviously familiar with now, and how to work with those equations.